And the very first image in front of me, there was the virus in all of its terror. The hairs on the back of my neck stood up. My memory of that moment is so clear that it's as if it was yesterday. We saw the awful destruction of the patient's liver and, in close proximity, large numbers of virus particles. What I did was just quietly walked out of the room and locked it.
Since the Second World War, a series of strange new lethal viruses has emerged throughout the world. Viruses against which we have little defense. The question haunting scientists is what else is lurking out there. These are some of America's finest scientists. Their speciality is the microbe. They gathered earlier this year for a top-level meeting in Washington to discuss a subject which is now of deep concern to them all.
The odds are changing and changing and changing in the favor of the viruses as opposed to man.
Everything we learn about the bugs themselves just makes them more scary.
A potential for another virus agent coming in today that could have devastating consequences is certainly there.
We can be quite certain that there will be new epidemics. We're not very well prepared to deal with them.
It has become impossible to keep up with viruses. New ones have suddenly appeared, and old ones we thought we had conquered are threatening to show up in unexpected places. In 1985, a shipment of used tyres arrived in the American South from Asia to be retreaded and resold. They carried with them an unwanted invader, the larvae of the Asian tiger mosquito, the carrier of dengue fever. Other tyres have been bringing back other larvae, which incubate quietly in wet nooks and crannies, and then begin to hatch. These are the larvae of the mosquito Aedes aegypti that can carry yellow fever. Now that the carrier is established across America, it would only take the introduction of the virus itself to cause a major outbreak.
There are emerging viruses and there are re-emerging viruses. And we are today at a higher risk of the re-emergence of yellow fever, for example, which is one of the great scourges of mankind for 300 years than we have been throughout any other time in this century.
At the turn of the century in Britain, the average life expectancy was 45. Infant mortality was 20 times higher than it is today. A constant fear in people's lives was of the germ and the microbe. No one understood much about them, but they brought death. Hospital wards were full of those suffering from septicemia, tuberculosis and pneumonia. Epidemics were frequent. In 1918, a mutant strain of the influenza virus swept across the world with devastating effects, killing 25 million people. It was known that some disease was caused by bacteria, single-celled creatures which could only be seen under the microscope. One could become 1 million in 12 hours, and their toxicity caused tuberculosis, cholera, plague. But for yellow fever, polio, influenza, there seemed to be no agent of disease at all. No microbe could be detected under the microscope. When scientists looked down the lens, all they could see was devastation. These are human cells under attack by an invisible enemy. It kills cells with stunning efficiency. For lack of any other information, it was named after the Latin word for poison, virus. What was in this mysterious liquid that could kill? A deadly chemical? Some strange germ? No one knew until in 1932 the Germans opened up a whole new world for science with the invention of the electron microscope. It used electrons to show up objects, although the objects themselves were killed in the process. With it they could peer into a universe smaller than the wavelength of light. It was in this universe that the viruses lay. For the first time, scientists could see each separate and distinct shape and recognize which virus caused each different disease. Rabies. Influenza. Pox virus. But even though we could now see the enemy, we were still helpless against it. We lived in a world with no cures. It took outside events to change that. In World War II, tens of thousands of soldiers were dying of infection and tropical diseases. Behind the scenes, battalions of scientists struggled to find breakthrough cures.
The world knows the skill and courage of our armed forces. But little is known of another army, just as important for victory, the men and women mobilized against disease. Instead of tanks and aeroplanes, they fight with microscope and test tube. In their hands, victory and life. Not death to the invading Nazi, but death to the insidious microbe.
Their success against the insidious microbe was almost miraculous. Penicillin and the range of antibiotics which followed had an astonishing effect. They weakened the skin of the bacteria to the point where the bacteria burst and the agent of disease died. Here was a stunning cure for septicemia, tuberculosis, cholera, diphtheria. In one fell swoop, half the diseases which had plagued mankind were under our control. Unfortunately, if applied to viruses, all these miracle drugs had absolutely no effect. These are hundreds of viruses gathered inside a living cell. It's the only time viruses have ever been filmed. This unique footage, shot in 1966, took a year to make, in a vibration-proof room using time-lapse photography and focusing on one of the biggest viruses, vaccinia, which hovers on the edge of the visible. Viruses have no life outside a host. They lie dormant until they're sucked into a living cell, the cell of a plant or animal, and then they too apparently magically come to life.
I believe that viruses probably go back to the origin of life. They're chemicals that can replicate. They're the simplest forms of life. The reason viruses cause disease is not that they set out to do that. They set out to survive. In the process, they must grow in cells. When they grow in cells, they often kill the cell, and that damages cells within your tissues and organs, and you get what we call disease. Or in some cases, in rare cases, they cause cancer.
A virus is a simple but strange organism, just a strand of genetic material, DNA or RNA, wrapped in a protein coat. On its own, it can neither survive nor replicate, It's just a tiny clump of chemicals. When it enters its specific host cell, it takes over, grabbing spare chemicals from the cell itself and linking them together to make clones of its own unique genetic pattern. Hundreds of these clones then bud out of the cell, ready to infect others.
Because they are part of us, we can't intervene with antibiotics as we can with bacteria. Bacteria are separate living cells. The virus is not a separate living cell. It becomes part of your cells and my cells. Now, in order to intervene, to make an antiviral chemical, antiviral agent, we must go in there and sort out all that DNA and RNA inside the cell and say, I'm going to zap this little piece right here and nothing else. I'm not going to damage your DNA at all. A very tall order, very difficult.
If it's so difficult to destroy a virus once it's inside a cell, the alternative is to prevent a virus from entering the cell in the first place, with a vaccine. A vaccine is like the empty shell of a virus. The lethal strand of genetic material inside is either killed or weakened. When injected into the body, this harmless vaccine fools the body's immune system into producing specific antibodies to attack and disable the intruder, its normal response to any foreign invader. When the real virus comes along, the antibodies are there and waiting to attack before the virus has a chance to enter a cell and start to replicate. Throughout the 50s, the pace of research into vaccines quickened, and with it came success. Mass production of vaccines for polio, yellow fever, smallpox. Mass immunization followed. Labs were set up around the world, and the era of optimism began. Science could do anything. Put rockets into space, protect our children from disease, and offer us a lifetime of safety, hygiene, and convenience. We could control the world.
Mr. Clean gets rid of dirt and grime and grease in just a minute.
Mr. Clean will clean your whole house and everything that's in it.
Welcome to this wonderful new world of push-button cooking, cleaning, and homemaking.
Can he clean a window sash?
Faster than a flash.
Can he clean a dirty mirror?
He'll make it bright and clearer.
Can he clean a diamond ring?
Mr. Clean cleans anything.
Mr. Clean will clean your whole house and everything that's in it.
Floors, doors, walls, halls, white sidewall, tires, and old golf balls.
Sinks, stoves, bathtubs he'll do. He'll even help clean laundry too.
Mr. Clean, Mr. Clean, Mr. Clean.
But in the background lurked the virus. Could scientists ever achieve the ultimate? Eradicate disease itself? Make a virus extinct?
Few people realize what a devastating disease smallpox was. As recently as 1967, when we began the program of eradication, the disease annually killed 2 to 2.5 million people every year. Some adults, children, and in a space of just 10 years and 9 months, we brought it from 2.5 million deaths to 0.
D.A. Henderson led the World Health Organization's fight against smallpox. The strategy was simple but painstaking. Because smallpox can only be passed from human to human, there was no animal reservoir to deal with. There was a good vaccine, so in theory, if you could vaccinate enough people in enough areas, the virus would have no host to live in, and the whole species would die out. WHO set out to vaccinate the world. It ended up with house-to-house searches in some of the remotest places on Earth to find the last few cases of smallpox and vaccinate everyone in the immediate vicinity. On the 31st of October 1977, Ali Maleen was discovered in Somalia. He survived the disease and became famous.
As I am concerned, I believe surely that it is the last case in the world.
Few people know that even today, the virus is still being retained in a laboratory in the United States and in one laboratory in the Soviet Union. These are the two laboratories that tested the specimens for the World Health Organization during the time of the eradication campaign. Now a decision has been reached to do a final few studies of that virus, and then in 1993 they will destroy it utterly. And at that point you will have the total extinction of a virus, a total extinction of a species.
These successes led to a general feeling that research priorities should now change.
I will also ask for an appropriation of an extra $100 million to launch an intensive campaign to find a cure for cancer, and I will ask later for whatever additional funds can effectively be used. The time has come in America when the same kind of concentrated effort that split the atom and took man to the moon should be turned toward conquering this dread disease.
During the 1960s and 70s, there was a lot of confidence expressed that we'd really conquered the infectious diseases in the industrialized world at least. And the industrialized world was putting up most of the money. And the able young people who were coming along were interested in prevention, interested in a causation of disease, were encouraged to go into a chronic disease field, to deal with cancer, to deal with heart disease. And consequently, this group, we lost a cadre of people coming in. And certain of the foundations stopped providing support for laboratories. Some of the countries that had laboratories closed those.
Even as funding shifted away from infectious disease, Nobel Prize winner Joshua Lederberg was warning of unknown plagues to come.
Comparing them with what you got out from this one?
Yeah.
I have been concerned about emerging viruses from perhaps about 20 years ago, at a time when many people seemed rather complacent that we had conquered viral infection. Part of our complacency comes from very important medical advances, which have given us a great deal in terms of our ability to control polio and measles and a wide variety of other scourges. Part of our complacency comes from a sense that nature is benign, and often it is, but we have no preferred place in nature, and it can be quite savage. Our only remaining serious competition for dominance of the planet at this time really are the viruses, and it has to be said that our own survival is not necessarily preordained.
Dr. Lederberg's fears were soon justified. In the 1950s and 60s, a series of strange new viruses began to emerge all over the world. Some were so dangerous that scientists had to devise complete protection to work with them. In Marburg, Germany, researchers working on a polio vaccine were struck down by an unknown virus. This same Marburg virus mysteriously reappeared in Africa 8 years later. Other lethal viruses began to emerge. They were named after the places in which they struck. Junin in Argentina, Arapuch in Brazil, Hantan in Korea, Rift Valley in Africa.
My personal experience with an emerging virus really began in the early 70s with Lassa fever. The case fatality rate was over 35% of the people who got it died. We didn't know how it was transmitted. There was no treatment, there was no vaccine. There were only rudimentary diagnostic tests. And I went by light plane to this little village in northern Liberia. I was alone in this investigation virtually. There was great panic. People were driving through the town, wouldn't stop. The town was dead. An American nurse had just died. There were a number of other cases among nurses and midwives on an obstetric ward. My job at first was really just to describe this outbreak and to set up some kind of a system which would prevent further spread of the disease. I felt the most important thing I could do was to try to find the reservoir, the source of this infection for human beings. This virus, Lassa virus, belonged to a family of other viruses for which rodents were the reservoir in nature. I went off to find the village where the index case, the first case in this epidemic, had lived, some distance away. Found her house, and we collected many rodents. We brought them into a crude laboratory. We wore the most rudimentary protective gowns and masks and gloves, took their organs, and isolated Lassa virus from their organs.
Tom Monath is one of a small band of international disease detectives who go out into the field to track mysterious new viruses. They venture in when everyone else has fled. It's dangerous work.
Boy, what a thing.
Carl Johnson, Joe McCormick and Fred Murphy are part of that select band. They were based here at the Center for Disease Control in Atlanta, Georgia. When they started here in Hot Lab number 8, 20 years ago, they had only the most basic equipment.
See the incredible contrast with our new maximum biocontainment laboratory building. Maybe it's a gap of 20 years, but it seems like a whole lifetime in between.
I think there are really two important areas. You cut your hand in the belly of an animal loaded with virus, you're likely going to die.
That monkey,
but you're certainly going to get sick.
But didn't we really think this was the state of the art at the time?
Yeah, it was.
Yeah.
Absolutely.
And the other thing we shouldn't forget is that it really worked, and it was safe.
You bet. Yeah. Nobody ever got hurt in here, and we got some critical answers.
In 1976, they were involved in the original research into the deadliest of all emerging viruses, Ebola.
And all of a sudden, one day, I got this phone call. And then we began to get reports that from Zaire in particular, at the hospital where this was going on in the bush, it was killing apparently 9 out of 10 people getting it. It had wiped out the entire hospital staff. And the word was that the hospital was no longer even functional.
When we needed to set up a lab, diagnostic lab in Zaire, I got this cable saying, hey, come down to Zaire, this is where the action is, and bring your box. We got up to the area of Nzara about 6 o'clock in the evening on this police plane that brought us in. And they took us immediately over to see the patients. And they were in this sort of mud hut with a thatched roof, which passed for a clinic. And it was dark. And unfortunately, we didn't have any flashlights, so we had to take these lanterns in to see the patients. They've got high fevers, they start to get dehydrated. In a matter of days, they can look like almost like skeletons. It's pretty terrifying, frankly. Usually around the 5th to 7th day of their illness, they go into massive shock. And at that point, even if you give them fluids, almost no matter what you do, they just can't come at it.
I remember when the box came in from Zaire. Patricia Webb and myself opened it up, and we thought it was just another unknown. So I just took a bit of it and made a couple of grids and stuck it in the electron microscope, really within a couple of hours of arrival. And when I first saw the image in the microscope, I was sure it was Marburg virus, because it's the only virus that looks like that.
The one that killed all those people in Germany.
In 1967.
Yeah.
And so I knew it was a dangerous virus. What I did was I just quietly walked out of the room, locked it, went back to where I had done all the preparative work, and flooded it with Clorox.
You got the Clorox out, started scrubbing.
Patricia Webb started the process of trying to identify it by serologic means. I had wet prints that made it look just like Marburg, and she says it's not Marburg, this is something new. And the drama of that moment was maybe the highlight of my life.
Oh, yes.
Professional.
Ebola is clearly an example, a marvelous example of a classical emerging virus. Science, the world knew nothing about it. And it all of a sudden happened as if it came from the skies. Everything that's been followed up has led to a dead end. So here we are 15 years later, and all we really know is that both Marburg and Ebola, very dangerous human viruses, are in Africa, but we don't know where they are or how they make their normal living when we're not having these sudden, unexplained, and very lethal outbreaks.
The question of the origin of emerging viruses might have remained the obsession of a few scientists, but for a tragedy that slowly began to unfold 10 years ago. It has focused the whole world's attention on emerging viruses and galvanized the scientific community like nothing else before.
The AIDS virus is the greatest challenge to public health. 1 million victims in Africa during the next. The runaway virus could threaten existence the world over.
There is no established cure.
A second AIDS virus has been identified in Britain.
No vaccines.
The wrath of God. Increasing evidence that some heterosexuals are at greater risk.
The disease was first recognized 10 years ago in America, but by then it had already struck Africa, where the epidemic is now of frightening proportions. 6 million are probably infected. AIDS, a devastating breakdown in the body's immune system, can be caused by 2 viruses, either HIV-2 or the more widespread HIV-1. The viruses attack T cells, the very cells that alert the body to defend itself against disease. Nothing like this has ever been seen before. Where do new viruses like HIV come from? No one yet has all the answers, but there are clues which seem to point to one possible but controversial explanation. The clues begin back in America, with Indian monkeys. Researchers in several American primate centres noticed that their Asian macaques were dying of a disease which looked suspiciously like AIDS. By 1985, scientists at the New England Primate Centre had isolated a virus in the monkey's tissue. It looked just like HIV. They called it SIV, Simian Immunodeficiency Virus. Strangely, some African monkeys carried nearly identical viruses in their blood, but they weren't ill. These monkeys seem to have adapted to the viruses. Other species were also found to carry antibodies to this family of viruses. For a virus to have dispersed and adapted to so many species might take hundreds, if not thousands of years. This suggested that SIV was an ancient African monkey virus. And when SIV was compared to HIV, it looked like the human virus could have evolved from the monkey virus. But how can a virus cross species? The answer lies in mutation. Every virus during the process of replication makes mistakes. They're called mutations. These are random and completely unpredictable. These mutations usually have no effect at all. Occasionally they make the virus more harmful, occasionally less harmful. A series of mutations can allow a virus to adapt to a new host, for instance to cross from monkey to man.
The remarkable thing about RNA viruses is almost every replication leads to a mutant progeny. So we start with a single particle, and as soon as it's been amplified to a few thousand, a few million, a few billion, we have a swarm of related mutants, not a single entity. To think of a virus is wrong. We must think of the swarm of viruses, all of which are competing with each other, some of which are more fit to move into new niches. To move from a mosquito to a human, from a mosquito to a mouse, involves adaptation, mutation. Probably several mutations at least are necessary to adapt as a virus moves from one host to another.
Once a monkey virus is capable of living in a human, then, theoretically, any blood contact between the two, a bite or a scratch, gives the virus its chance to cross species. As AIDS seems to have emerged in Africa about 20 years ago, could HIV have crossed species from monkey to man around the same time? Several groups of scientists have tried to find out. Every time a virus mutates, it shows up on the virus's genetic strand. By chemically breaking down this genetic strand, scientists can trace where each mutation occurred. This is the genetic fingerprint of a virus. Like any living creature, its genetic strand is made up of only 4 different chemical bases, recurring in a unique sequence, a unique pattern. It's possible to stop and read the sequence anywhere. T, T, G, C, C, G, G, G. HIV has 10,000 of these chemical bases. Humans have 3 billion. When a virus mutates, certain sequences remain the same, but others change. Comparing one tiny fragment of this sequence over a month shows how many times the virus mutates at this particular point. Many geneticists believe that on average, viruses mutate at a steady rate. So, by counting up all the mutations between HIV and SIV, they can try and work out how long ago the one diverged from the other. Recent analyses suggest that HIV-1 became a new human virus as long as 100 years ago. Some scientists think it could be even older.
I think the evidence that has accumulated about the HIV viruses suggests, in fact, that these viruses have been around for a very long time. We asked ourselves in about 1986 whether AIDS had been circulating back in 1976 in the area of Zaire where the Ebola epidemic had occurred. We took out the serum specimens which we'd collected at that time, which were a little over 600, and we tested them for the AIDS virus antibody and found a 0.8% antibody prevalence at that time. And we asked ourselves what has happened to this population since then. So we made an expedition back to the same area, rebled many of the same people but also the general population, and found in fact exactly the same percentage, 0.8%, was prevalent 10 years later. Now I think what that means is that under the right circumstances and with the type of typical behavior that you would find in those African rural villages, that this virus could go along quite happily without causing epidemic disease. It would cause disease in a few people, but it would go almost unnoticed and certainly wouldn't produce the kind of problem that we see now.
This field work shows that even a devastating disease like AIDS can quietly tick over in the background without causing an epidemic. Other work indicates that Ebola, Marburg, Lassa, all the other viruses which have emerged just since the Second World War are also old viruses that for some reason we've never seen before.
I think one of the most interesting things we've discovered in recent years about emerging viruses is that they're not the result of new mutations or a viral evolution that will suddenly create an evolutionary novelty. This is what many virologists have thought for a long time, and I think it reflects the training that most of us receive in molecular biology and our interests in those aspects of viruses. But in fact, most emerging viruses have really always been in nature. They're not new mutants. They're just old viruses in new settings.
R0 is greater than 1 is an equation which has been used for decades to represent the point at which a virus emerges from obscurity to cause an epidemic.
Mathematics can't help us to predict when a new mutation is going to occur, but what it can do in the population level sense, it can help us define the components that contribute to reproductive success, and that enables us to actually think about the particular things in society that might be changing, which would enhance the likelihood that a new emerging virus would spread and cause a lot of disease. And those components could be to do with the biology of the virus in the host, they could be due to human behavior, or they could even be due to climatic change, how that might influence it.
And as these change, as crowding changes, as human behavior changes, a virus that, if it had appeared by mutation at an earlier time, would not have taken off, in an altered circumstance, does take off.
What would go into the equation for AIDS? Unlike smallpox, which is only infectious for a few weeks, AIDS is probably infectious for the lifetime of the host. It's transmitted through sexual or blood contact, and from mother to child. What happened in Africa to make a virus like this suddenly become an epidemic?
Africa has seen a dramatic change. There's been increasing urbanization in many African countries. Originally, Africa had perhaps 80% of its population in rural areas and perhaps 20% or less in towns. Gradually, that's changing, with males migrating to urban centers to seek work, having sexual contact with female prostitutes, and then going back to their rural villages at some time and having sexual contact with their wives or partners. And so the pattern of spread could have been something like this. It evolved in Central Africa many hundreds of years ago or more. It then trickled and spluttered between villages over a very long period of time, perhaps afflicting a very, very small fraction of people. And then slowly over time, it sort of moved into these high-risk population because of the social changes in Africa, in the urban centers, and exploded, as we saw in the Nairobi female prostitutes, where it rose from essentially 0 to 80% infected in the space of 5 years.
What common link could there be between the explosion of AIDS and the emergence of these other, totally unrelated viruses?
Man himself is responsible in many ways for the emergence of these new diseases. Imposed on civilization, new methods of transportation, especially air travel, the changes in the environment as a result of urbanization and poor sanitation, our disposable society, which creates containers for breeding mosquitoes. An excellent example is the situation in eastern Sierra Leone in West Africa, where Lassa fever is one of the leading causes of disease in the native population. And here in the 1950s, a diamond mining industry emerged, with the result that there were new towns, a great influx of people who were working out, digging holes all through the forest, who were living in close contact now with the rodent that was carrying this virus, Lassa fever virus. And it was in the context of the disturbances and the new interaction of man and his environment there as a result of the diamond mining industry that led to the emergence of that disease.
Another human factor seems to have led to the emergence of Rift Valley fever in Egypt in 1977, the building of the Aswan Dam. It gave mosquitoes an enormous inland lake as a breeding ground. It was the classic example of the equation. More water means more mosquitoes, means more disease. And Ebola seems to have emerged when modernization in a rural area offered the virus its chance for direct blood-to-blood transmission on a scale that had never existed before.
The Ebola outbreak was the result of introducing a hospital in a very remote part of Zaire, where one of the practices was using needles both in the inpatient as well as the outpatient departments. And it was a common practice, in part because of the poverty of the area, to share these needles between individuals, so that it would not be unusual for someone just simply to take a couple of needles to start their morning surgery and use those needles to give their vitamin B or whatever they would give during the morning when they were seeing patients. They might wipe off the needle or whatever, but they would reuse it. And we believe that the Ebola was spread in this way, particularly it was spread out to the villages because people came to the hospital for their prenatal care or some other, or perhaps they had a little fever. They got an injection of a antimalarial or some other or some other medication. Along with it, probably got their Ebola, then went home and incubated it, and got sick in their home and spread it to their family members.
There are probably thousands of viruses on Earth. Only a few hundred have been identified. In attempting to create our modern post-war world, we began massive exploitation of the planet, and in so doing, stumbled upon viruses which we would never otherwise have encountered. Building dams, deforesting, changing the Earth's climate, and the migration patterns of animals will only bring closer encounters with unknown viruses.
What we finally understand is that the emergence of these new virus diseases has gone hand in hand with massive increase in human populations in these parts of the world, together with the inevitable and massive changes that these populations are creating in the natural ecosystems which have been on this earth for so long. They too go hand in hand, so that we are like gardeners, or wreckers, if you will, going in and fishing out from the rubble everything that's possibly there.
If you were a virus living in a dwindling monkey population, what's your best hope for survival in today's world? There's some nice, fat, juicy hosts out there, and we call them humans. The burgeoning human population is, in essence, a gigantic test tube in which viruses can try their hand at adapting to one of the better populations of hosts on Earth.
Could we one day stumble upon that unknown virus whose strategy is perfectly adapted to wipe out mankind?
I don't know how many viruses there are floating around in that part of the world that we still don't understand. We still don't know anything about that could, in fact, be lethal, or certainly affect man really very severely.
Joe, given the what we know about HIV, Ebola virus, it is even possible that someday in the future a virus will emerge that brings together the qualities, the worst qualities of all of these viruses we've been talking about. The lethality of HIV and Ebola, the transmissibility of influenza virus, which can sweep around the whole world in one season. If you put some of these characteristics together in a theoretical, imaginary virus, you could get worse.
To the point where humanity might lose the Earth to the viruses?
I think you wouldn't want to underestimate the human defense. We have our immune system, and we have medical science to put up a hell of a good battle.
The only problem with that is that we know of at least one virus that's winning the battle right now in terms of the immune system and medical science to be able to treat it or prevent it, and that's HIV.
With all of the array of different viruses ready to emerge, ready to mutate, ready to evolve, we can be quite certain that there will be future epidemics on a grand scale. We have a limited capacity to forfend the damage that they can do.
It is possible in theory that a virus could have the trade-offs between damage to the host and transmitting itself set in such a way that evolution drove it first to extinguish the host population and then to go extinct itself. That the mathematical models and basic evolutionary theory admit that as a possibility. It's even likely that one has seen that in other infections in bird populations. It is not the sort of thing that keeps me awake at night for human populations, because I believe that we differ from the rest of the animal world in that we have a conscious awareness of what is going on around us. We can have a detailed understanding of the natural world that no other animal species has, and long before anything does us in, we're going to respond with either a cure or at least behavioral changes.
But can science keep up with viruses? If more emerge, as we change the ecology of the planet, there'll be new threats posing different scientific challenges, and the world may be less prepared to meet them.
There are fewer laboratories capable of diagnosing the tropical diseases than we had 20 years ago. More important, perhaps, is the fact that we do have new tools, new techniques in biotechnology to examine specimens. And these are not being taken up by those laboratories simply because of the expensive equipment, problems of training, and problems of location.
With the winding down of tropical field labs, new viruses may become well established before they're ever detected. While detection alone doesn't equal a cure, it is the front-line means of control.
We need to make a major investment in the surveillance and detection of new virus agents and research on these and the preparation of vaccines. We need to do this now, and we'll need to do this for the indefinite future.
Washington, D.C. In the light of what D.A. Henderson has proposed, the National Academy of Sciences has brought together microbiologists and economists to look at ways of building a credible world surveillance system for emerging diseases.
We cannot say we cannot afford such a system. We cannot afford not to have such a system.
Just 35 miles away from this scientific gathering, another strange new virus has recently emerged. In the back streets of Baltimore, rats now carry a virus closely related to one which killed hundreds of UN troops in the Korean War. But this virus doesn't cause spectacular fevers or hemorrhaging. Sole virus is a true virus for our times. It's associated with hypertension and strokes. What made it emerge? No one's sure. But it has now travelled round the world from its origins in Asia. It's not only lapping American shores, it's also been found in Britain.
We cannot change modern times. We cannot change the pace of modern life. We cannot change the fact that the world is becoming an ever smaller place. What we can do is to become more aware that the world is one place. No place is very far away or very isolated, and we should be looking and prepared for the new viruses that emerge.
We do ignore the health of the third world at our own peril. It will come back to haunt us. The virus that felled a child in a distant village yesterday can reach your own family today and be the seed of a global pandemic tomorrow.